In this video, we're going to be drawing Lewis structures, and there's a step-by-step procedure to draw a correct Lewis structure. And if you follow this step-by-step procedure, you will always get the correct Lewis structure. So instead of going through the steps right now, which won't make a lot of sense, what we're going to do is we're going to just go straight into an example and then go back and follow the steps. So our first example for drawing this Lewis structure for a more complicated molecule is carbon dioxide. So we'll look at step 1. Step 1 says, arrange the atoms around the central atom. Note, the central atom is usually the first atom listed in the formula or the one with the highest bonding capacity. It's typically not oxygen and it's never hydrogen. So arrange the atoms around the central atom. Well, the first atom listed here is carbon. Let's check to see if carbon does in fact have the highest bonding capacity. We go up and we see carbon. Yep, between carbon and oxygen, carbon has the higher bonding capacity than oxygen. So we will put an oxygen here, a carbon in the middle, and then an oxygen. And we are done step 1. Step 2. Count the number of valence electrons of all the atoms. Add extra electrons if it has a negative charge, or subtract the electrons if it has a positive charge. So what we're going to do is we're going to count the valence electrons on each of these atoms. That's for step 2. So we take a look at carbon. Carbon has 4 valence electrons. Oxygen has 6 valence electrons, but we have to multiply it by 2 because we have 2 oxygen atoms. So 6 times 2 is 12, plus 4 is 16 electrons. So we will be able to place 16 electrons within this molecule. Step 3. Place a pair of electrons between the central atom and the surrounding atoms. So step 3, I'm going to place my pair. And when I place my pair of electrons, I'm going to draw them as a line because that represents the 2 electrons involved in the bond. So I had 16 electrons to place, and I've now placed 2, 4. So I have placed 4 electrons, and now I have 12 electrons left to place. Step 3. Complete the octets. Octets means just create a full outer shell, and generally that means, typically it means 8 electrons. Sometimes it can mean 2, or sometimes in the case of boron it means something else, but complete the octets of the surrounding atoms. So these right here are your surrounding atoms, and so I will redraw that. So step 3. We have oxygen, carbon, and oxygen. Okay, they have their bonds here. These are the surrounding atoms right here. The oxygen are your surrounding atoms, and that's because carbon was your central atom. So we need to complete the octets of these surrounding atoms. So complete their outer shells. Right now they have 2 electrons, so they need 2, 4, 6, and now altogether they will have 8, or they will have an octet, right? That's where that name comes from. It has 8 electrons around it. So 2, 4, 6, 8, that is an octet around the oxygen. Around this oxygen, 2, 4, 6 electrons around here. Okay, and now we will count how many electrons. So we had 16 electrons to start. Then we subtracted 4 electrons, as we saw here in the previous step. And now we're going to subtract 2, 4, 6, 8, 10, 12 electrons, subtracting 12 electrons. So let's see, do we have any electrons left to place? No, we have 0 electrons. Okay, apologies, that wasn't step 3, that should be step 4. Minor correction. All right, step 5. If the central atom does not have an octet, move lone pairs from the surrounding atoms to form double or triple bonds until the central atom has a complete octet. So this central atom here does not have a full outer shell, because remember that these atoms want to have 8 electrons around them. This central atom here only has 2, 4 electrons. Okay. So what this molecule, what needs to happen in this molecule is we have the oxygen here with its 6 bonded to carbon, bonded to oxygen. It says move lone pairs from the surrounding atoms to form a double or a triple bond. So if I move a lone pair here, I get this, and I do the same on the other side as well. As much as possible, you try to aim for symmetry as best as possible. In this case, we end up with this now. Okay. So 2, 4, 2, 4, 2, 4, right? But then this oxygen has 2, 4, 6, 8. This oxygen has 2, 4, 6, 8. And this carbon has 2, 4, 6, 8. So we look at each of the atoms and we check. So we'll do a little check here. And you should always do this. Does each atom have an octet? And does each atom fulfill its bonding capacity? So if we take a look here, oxygen has 2, 4, 6, 8. Carbon has 2, 4, 6, 8. Oxygen has 2, 4, 6, 8. So all of the atoms in the molecule complete their octet. Now let's look at bonding capacity. Let's go back up to the top. Oxygen has a bonding capacity of 2, whereas carbon has a bonding capacity of 4. Let's see if oxygen is making 2 bonds, and let's see if carbon is making 4 bonds, because they should be according to their bonding capacity. Well, here oxygen is making 2 bonds, oxygen is making 2 bonds, and carbon is making 2 4 bonds. So yes, both atoms are fulfilling their bonding capacity, and so this is the Lewis structure, and then this would be the structural diagram for carbon dioxide. So it's a carbon with a double bond on the left side and with a double bond on the right side. Okay, let's go down to this is HCN right here. Okay, and so we look at these 3 elements and we have to figure out for step 1 which one is the central atom, which one's going to go in the middle. So remember, the one in the middle has to have the highest bonding capacity. It is never hydrogen, so we'll skip this one. So between carbon and nitrogen, which one is going to go in the middle? Let's go back, check the bonding capacity. Carbon has a bonding capacity of 4. Nitrogen has a bonding capacity of 3. So carbon is going to go in the middle. And we're going to put a nitrogen here and a hydrogen there. Okay, so that was step 1. Step 2 is to count up all the valence electrons. So carbon has 4 valence electrons, nitrogen has 5 valence electrons, and hydrogen has 1 valence electron, for a total of 10 valence electrons. So I have 10 electrons to place within this molecule. That was step 2. Step 3 is to place the bonding pair. So I place a pair here and a pair here. So I bond the atoms together. 2 4 electrons placed. And now I have 6 electrons left to place. The step after that is to complete the octets of the surrounding atoms. So I look at the surrounding atoms and I want them to have a full outer shell of 8 electrons. This is the exception. Hydrogen is an exception and should only have 2. So hydrogen already has a full outer shell, remember, because it only has that first shell and has a full outer shell. So I look at the other surrounding atom, and that I complete the octet. So 2 4 6. I've now placed 6 electrons, so I have 0 electrons left to place. When I go to do my check, I'll check to see that everything has a complete octet. So nitrogen, 2 4 6 8. Nitrogen is okay because it has 8 electrons around it. Let's look at hydrogen. Hydrogen only has 2 electrons around it, but it only wants 2 electrons around it. Carbon is a problem because carbon only has 2 4 electrons around it. So it needs another 4 electrons. And in order to get those 4 electrons, we're going to take these lone pairs and we are going to move them over here to form a triple bond. HC, triple bond to nitrogen here. And that is our molecule. Hydrogen bonded to carbon, triple bonded to nitrogen. We're going to do our check here. Let's check to see that all elements have a complete octet, and let's check to see that all elements are obeying their bonding capacity. Hydrogen only has the 2 electrons, and that's okay because it only wants 2. Nitrogen has 2 4 6 8, so nitrogen has 8. And carbon has 2 4 6 8, so carbon has an octet. Hydrogen has a bonding capacity of 1, so it's made its 1 bond. Nitrogen has a bonding capacity, let's double check. Nitrogen has a bonding capacity of 3. So nitrogen has formed its 3 bonds. And carbon has a bonding capacity of 4, and it's made its 4 bonds. So its bonding capacity is complete as well. The last one is sulfur dioxide. And I've given this to you guys as basically like a reach ahead for next year. There are some compounds and some atoms that do not obey their bonding capacity, and there's no other way for them to bond but to break their bonding capacity. So in this case, what we do is we put sulfur in the middle, and then we put oxygens around it. Okay. We count up the electrons. Sulfur has 6 electrons. Oxygen has 6 electrons, but we multiply it by 2, and we get 12 electrons. Adding them together, we will have 18 electrons to place. Remember, we start by doing the bonds between the atoms. So we put the bonds between the atoms, and that is 4 electrons placed. That leaves us with 14 electrons. When we have 14 electrons, we then go 2, 4, 6, 8, 10, 12, because remember, we have to, according to step 4, complete the octets of the surrounding atoms. This, however, gives us with a remainder of 2 electrons. So what do we do with the remaining electrons? Remaining electron pairs right here, remaining electron pairs should go on the central atom. So I have 2 electrons left, and they're going to go right here. So those 2 electrons go right there, and we have 0 electrons. What ends up happening is that when we look at oxygen, oxygen has 8 electrons, and this oxygen has 8 electrons, but the problem with this sulfur here is that it only has 2, 4, 6 electrons. So we're going to remove a bonding, or rather a lone pair over to make a double bond. And it actually doesn't matter which side you do it on, you just move them over to one side. And what you will end up with is oxygen bonded to sulfur, bonded to another oxygen. And here your oxygen has 2, 4, 6, 8. This sulfur has 2, 4, 6, 8. And this oxygen has 2, 4, 6, 8. All right, so we have completed the octets. We have not, however, been able to fulfill the bonding capacities, but I mentioned over here already that it wouldn't do that, so we're okay there. This is the shape of the molecule. On the next page, there are a series of questions, right, that ask for the Lewis structures and the structural diagrams. Just recall, this is your Lewis structure, and your structural diagram just doesn't have the lone pairs. It's just like that, okay? And so you have a number of structures here to complete using the rules that we gave you in the previous over here. So just follow these steps. If you follow the steps, you should be okay. If you start kind of like skipping around, then you might run into some issues. So just follow the steps and you should arrive at the correct answer, or the correct Lewis structure. Okay, again, thanks for watching.